Welcome to the Daily MBA, where business wisdom is served fresh and fast, straight from one of the top MBA programs in the world. I'll give you summaries of my lectures and readings, as well as the most important insights gained from an MBA, so you can apply all of this knowledge in every business. Let's get started. On today's episode, I'll continue giving you some of the basic things that you need to know about stats, so you can then start taking better decisions as a manager by doing all of this statistical inferences, regressions, and many more things that you can do around stats. So last episode, I was telling you first that stats is the only math that you can actually use in real life, so for once, it's useful. Second, that there are two probability distributions that we want to focus in. They're going to be the Bernoulli one, which is going to be used for binary, and the normal one, which is going to use for quantitative and continuous variables. And then what we wanted to do with this one, our ultimate goal with stats is going to be answering population questions based on the sample data that we're going to have. And then I mentioned something important that was another thing that we can get, and is the sampling distribution of the means. So this is when we plotted means of many different samples together, and when we had many samples, which was the central limit theorem, all of this would behave like a normal distribution. So if what I'm talking doesn't make sense, I would recommend first listening to my previous episodes. If this is basic enough for you, then you can continue over here where I'll continue introducing some of the important concepts. And the first one that I wanted to talk about today is going to be standard error. So last time I was establishing all of the relationships that we had between our sample measures and our population measures. I told you first, the mean is going to be super easy, and that's why we love the mean, because the sample mean is going to be the same as the population mean. But the standard deviation of the sample is not going to be the standard deviation of the population. Here, we would have to divide the standard deviation of the population by the square root of the sample. And so this brings a big issue, because let's go back to one of the first things that I just told you. Our goal is to get population information from the little samples that we have. And so how are we supposed to know the sample standard deviation if this one relies on knowing the population standard deviation? This makes absolutely no sense. It's turning things around. We're trying to get to all of the population measures, but for some weird reason, we actually need the population one to get to the sample. So it becomes like a chicken and egg problem. How can we figure this out? And so, of course, we may not have the population standard deviation, and for this, what the mathematicians figured out is that we would have something called the standard error. So the standard error is going to be your best estimation of sigma, which I told you is going to be the standard deviation of the population. So we don't have that one. We're trying to get an estimate, and so it's going to be standard error. And so I'm going to share the standard error formulas over here. I'm not going to talk about them because basically you just have to plug in the numbers and you would get it. But the interpretation about this would be that the smaller the standard error, the smaller is the error to be using the sample mean to estimate the population. So if it's very small, we know we're on the right track. This is being good. And so the standard error is going to be useful for us for doing some calculations where we might need sigma. So you just have to keep in your head that standard error, usually abbreviated as SE, is going to be our most reliable source for getting sigma. And so now that I finished this and joining it with my previous episode, we would have 4 important measures of variation. The first one was the population standard variation, which was represented by sigma, and this means all individual observations have this standard deviation. The second one was the sample standard deviation. And so I told you we would usually need some calculations for this one. This one will be represented for stats people with an S. Then, the third measure that we would have was the standard deviation of the distribution of the sample mean. So I told you these are going to be completely different things. One thing is going to be the sample, the other one, the distribution of the sample means. And so this one is the one where I was telling you we have to divide sigma by the square root of n. And this, what it's telling us, is the standard deviation of all possible sample means. And the last and fourth measure that I have is the standard error that I just gave it to you. This is going to be the estimation of the first one. So if you already understand this, you're basically understanding everything. We have a population, we have a sample, and we have a distribution of sample means. The thing is, standard deviation is making things a little bit harder, so we have to get a fourth one to estimate the first one. So just getting many, many numbers out there. But as soon as you understand that we have these three different things, population, sample, and sample means, it starts getting organized in your head. And so, now that we know this basics, let's see how it would actually look with a real-life problem. And so, for this, I'm going to introduce a second concept, which is the one that I want to work with in my second half of the episode. And this one is going to be called standardization. So standardization, probably you heard about it in high school or maybe in your undergrad, is going to be how do we transform data into numbers that can have a better and smaller scale. Because if numbers are all over the place, we can't really compare them. Standardization would turn them into numbers that are more easy to compare. So we can have two methods for standardization. One of them is going to work for binary data. The other one is going to work for quantitative data. And so in real life, it would be the exact same formula. But stats people have different names for everything, as you've probably noticed in my previous episode and in this episode. And so what we're going to do with these names is that for binary data, this is going to be called a Z-score, or SED, however you call it. Z-scores are going to be in a Z distribution. So this is going to be a normal standard distribution. Or for the other side, we may also have the T-scores. And so T-statistics or T-scores are going to be plotted in also a graph, but this one is going to be around T. So now we have two new letters. We have Z and we have T. And so what happens is that we're going to have these two types of distributions, which will look almost the same. One of them is the standard normal distribution. This one's for the Z-scores, so for binary data. The other one is going to be called a T distribution, which is going to work for T values or T scores. And this one is for qualitative data. So when we look at it in real life, it's going to be the same formula almost, just the thing is going to be changing the name of the distribution. Okay, so this is key because if you say something wrong in stats, it's going to mess up everything. We will have a T1 and a Z1. So I'm going to start with the Z1, and for this, I'm going to use an example. So let's say that I'm a company, and I'm trying to see what is the rate of defaults in a bank. So this information is going to be binary. Either 1, someone defaulted, or 0, they didn't default. So 0, 1, 0, 1, I'm gathering my small sample of data. And from that sample, I would get a mean. So how many people actually defaulted from the loan? For now, I think we're going simple. I'm not saying anything that's weird. And so what I want to know is what is the big probability of default in my bank, not only for the 100 people that I interviewed. So what I have to look over here is how to do this statistical analysis. So I already have my mean. We're going to assume that the mean from my sample will be the mean of the population. But now I have to get the standard deviation. And I told you I don't have this measure, so I have to get the standard error. The standard error for binary data, I'll put all of the equations right next to me so you can look at them and follow them. But it's going to be the square root of the mean times 1 minus that value, and then all of that divided by the square root of the sample size. So this is just plugging in the numbers. It will give me my standard deviation. And then I want to know one important number, and it's going to be the percentage of confidence that I want to have. So what's usually and commonly used in stats is 95% of confidence. This is going to be the confidence level. So I want to be 95% sure that the bank default rate will be somewhere in a range that I'll give. And for creating that range, that is called the confidence interval, because I'm literally saying I want to be this confident that the value will fall between this range. So I'm basically going to create a confidence interval, and for that, we're going to take our mean plus 1.96, just because that is the 95% confidence number. You can memorize it if it's easier for you. Always for C-scores, it's going to be 1.96, and then times our standard error. So this is going to give me one number that's going to be in the top of that interval. This is going to be the higher level of the interval, and for getting the lower one, I'm going to do the exact same thing, but I'm going to take the mean minus 1.96 times the standard deviation. So here it's going to be kind of like the other way around. I'm not adding it, I'm subtracting it. And so this is going to give me an interval. And how would you interpret all of those numbers? Let's go back to my bank example. I would say I am 95% sure that between this number and this number of my bank loans are going to be defaulted. That would be how you can assume it. And I'm making this assumption from my sample into the population. I'm trying to get to know what is the percentage of bank defaults. So this would be one of the ways that you can apply it. The second way, in the second example that I'm going to give to you, is not going to be binary data, but for quantitative data. So this is going to be for height, for example. And so let's take same type of experiment. I'm measuring the height of 100 persons because I want to know what is the average height of the population. And so for this, I'm going to take my 100, and I already have my mean. Mean, I told you, is going to be shared by all of these ones. Now, for estimating my standard error, I will also have to do some calculations. And this is going to be my sample standard deviation. So whichever it is that I got, I'm going to take all my numbers, take the sample standard deviation, and then divide it by the square root of the sample size. So in my case, it was 100. And then, what if we also want to reach 95% confidence? Here is where things change just a little bit. Because I was telling you, we have C-scores and we have T-scores. When we're going to look at the T-scores, which are for quantitative data, now we won't use 1.96, but we're going to use 1.98. And so for stats people, this 0.02 difference is going to be crucial. So that's why I was telling you, you can't mess it up. If it's binary data, it will be 1.96 for getting 95% confidence. If it's quantitative data, you're going to use 1.98 for getting 95% confidence. And so we're going to do the same for building up this interval. We're just going to take the mean, then we'll add it and subtract it, from the value that we already have, 1.98, times the standard error. So this is going to be same process and the interpretation would be the same. I can be 95% confident that the average height of the population is going to fall in between this range. All right, so here today we studied all of these confidence intervals, and in the first half, what is the importance of the standard error for being able to get all of these measures. In my next lesson, we're going to look into hypothesis testing so we can start applying statistics into more business situations. I'll see you next week.